All right, let's investigate inscribed angles, and I'm going to review going back to central angles. Okay, so an inscribed angle is the angle formed right here, right, that is formed between two separate chords. Okay, inscribed is that guy. Central angle, of course, is coming from the center. All right, so here's what we got. The inscribed angle is actually half of the arc length. So if the measure of this arc is 100, the inscribed angle is 50. Whereas the central angle, if the arc length is, let's say, 80, then the central angle is 80. So for a central angle, the angle equals the measure of the arc. For an inscribed angle, the angle is half the measure of the arc. Okay, looking at them together, right? This kind of, I don't know, I always thought that kind of looked like Pac-Man somehow. That if this is 50, then this angle is 50. But that means that angle down here, right? This is the central angle, and this is the inscribed angle. The inscribed angle is half. The central angle is equal to the measure of the arc. Again, that's the central angle, angle ACB. The measure of the arc is 50. They're the same. And then ADB is the inscribed angle, and it's half. All right, so let's look at a diameter. Okay, so if I take a diameter, isn't like this the central angle? But that's just a straight angle. So that means the central angle is 180. You're like, well, duh. Look at the measure of the arc. It's half the circle. Of course, the measure of the arc is 180 if the central angle is 180. But check this out. Doesn't that mean that this has to be 90 degrees? Because half of 180 is 90. So if you take any circle, draw any of the diameters, right? And then take those endpoints and connect them to any point on the circle. Anywhere down here, boom. What will that angle for sure be? Well, it has to be a right angle because that inscribed angle has to be half of the arc. And again, its arc is this guy. No matter what, because the diameter, if this has to be 180 because it's half the circle because that was the diameter, which means that guy is always 90. Again, right here, I kind of say it in words right there. The cool part is I can put point D anywhere I want on this circle, and I guarantee it will produce a 90-degree angle because its arc is 180, and we know the inscribed angle is half. That's kind of, I think, the coolest property for this one. Okay, we also got something like this. Okay, so how does the black angle, we'll call that one X, and the red one, we'll call that one Y, how do they compare? Think about that for a second. You're like, wait a second. Don't those two angles have the same arc? Don't they both have this arc at green? Don't they both intercept the same arc, right? The black goes from there to there, and like, but the red goes from there to there, and you're like, oh, look at that. They have the same arc, so they have to be the same angle, right? If they intercept the same arc, they have to have the same angle, of course, because we know that the angle is half the arc. We know that to be true. All right, so that's the problem you'll end up seeing. And then this guy, an inscribed quadrilateral, is a quadrilateral whose vertices are on a circle. So in this case, right, a quadrilateral is just a four-sided polygon. So this is not a rectangle, it just happens to be a quadrilateral. I mean, it could be a rectangle is a quadrilateral, but I just took four random points, connected them, and what I know for sure is that opposite angles are supplements, which also is a biconditional. So we know that if we have a quadrilateral that opposites angles are supplementary, I know I can inscribe it with a circle, or most of the time, if I have an inscribed quadrilateral, meaning I have a quadrilateral drawn on that circle, I guarantee that opposite angles are supplements. So I know that 1 plus 3 is 180, those two, and I know that 2 plus 4 is 180. And I also know that they all add up to 360. That's just a property also of a quadrilateral, which again, you can kind of prove that pretty easy because any quadrilateral can just be, any random quadrilateral can just be two triangles. And we know triangles are 180, well then if you take 180 there and 180 there, you got 360. So we know that they have to add up to 360, but more importantly, we know that the opposite angles are supplements as long as a quadrilateral can be inscribed in a triangle or in a circle. All right, so let's just do two kind of problems. Nothing too big. All right, so this is the measure of the arc, and this is the measure of the inscribed angle. And what did we say again? We said the inscribed angle is half the arc. All right, didn't we say that? First thing I'm going to do, I'm not going to multiply. I'm going to multiply that over. I'm going to multiply both sides by 2. And you probably could have even just started that. You could have just said that doubling the inscribed angle equals the measure of the arc, and then we can, finish this. I'm going to add 20 to make that 40, and then I'm going to subtract 2 and make that x. You're like, okay, x is 40, which means that guy in there was 50, and if you plug in 40 here, you're like, oh, that's 100, and you're like, oh, that makes sense. Check. The inscribed angle, 50, is half of the arc. And over here, like, oh, check that out. I got a quadrilateral, and it's inscribed in a circle. That means I know opposite angles are supplements, okay? So I know that 3x plus 2x plus 10 has to equal 180. So this is 5x, 170, and what is that, 34? X equals 34. Okay, so those are some problems you can do with inscribed angles and central angles. I'd say the 3 most popular pictures for this unit are this one, an inscribed quadrilateral, one like this where 2 inscribed angles have the same arc, which means they're the same angle, and then stuff like just relating central angles and arcs and inscribed angles. Oh, and I think this one is probably pretty cool. The fact that if you have a diameter, that any point does form a right angle. Okay, so you can kind of review those properties and get started on the worksheets.